3.
Okay, good evening.
Good evening.
How are you?
We are fine, thank you.
Okay, so welcome to today's class. So before we start, let me call the register to confirm if everyone is in. So we have Eric, present. We have Tino,
Present.
we have Mercy,
Present.
Caroline,
Present.
Wendy.
Present.
So since everyone is in, so we are going to start our session right away. So before we start, who can remind us what we learned in our last class or in our last session? Yes?
In the last session, we talked about factorials.
Yes, factorials. And we said factorials are denoted by
Yes.
n, which means that, what does it mean?
Exclamation.
Use exclamation. It's here in mathematics we call it factorials. So how do we calculate for factorials? Yes?
You start with n, then you multiply it by n minus 1.
So it is n multiplied by all the numbers below it
Yes.
to 1. So we have n minus 1 multiplied by n minus 2 all the way multiplied by
N to n.
to 1. Was it like that?
Yes.
Yes, so today, based on 7, we are going to employ the same concept in a new subtopic that is on permutations. And our learning outcomes will be, by the end of this session, we should be able to, so our learning outcome is that by the end, the session, the learner should be able to, so number 1, we should be able to define and explain the concept of permutations. Again, you should be in a position to calculate the number of possible permutations using the formula. And the formula we will look at the formula, how it look like, and then we are supposed to apply permutations to solve real life problems. Real life problems. So these are our outcomes. By the end of this session, we should be in a position to, 1, to define the concept of permutation. We are going also to look at how to denote and how to use the formula to calculate the number of possible outcomes of a given data set. Now, we are going to start by defining what permutations are. Maybe I can ask, what do you understand by this term permutation? Yes?
Permutation is the arrangement of items in a specific order.
Very good. Simply, this one is the arrangement of objects in a specific order. So for permutation, order matters a lot. This is the arrangement of objects in a specific order. So for this one, order matters. Order matters. So you will look at another term, the opposite of permutation. You will come and look at what we call combination. But this one is for another class. So for combination, no order. No order is followed. So for permutation, we will strictly follow an order. For example, so we have an example. We have been asked to arrange these letters. Arrange the following letters. So I want us to arrange the following letters in order without repetition. The letters are A, B, and C. I want us to arrange these letters without repetition in order using the concept of permutation. How can we arrange? How many ways are we going to arrange these letters in order without repetition? Before we look at the formula, we can arrange the letters without repetition. You can start. So the first outcome can be, who can guess? Yes? So we have the first one being A, B, C. The second one, yes?
ACB.
We have A, C, B. Another one, yes, Mercy?
We have DAC.
We have B, A, C. Without repetition, yes? Atieno?
CA.
We have B, C, A. Another one, yes, Wendy? C, A, B. And then?
We have CB.
C, B, A. Do you have any other way we can arrange it? No. So how many ways have we arranged? We have 1, 2, 3, 4, 5, 6. We have 6 ways. So we have 6 ways to arrange these numbers without repetition. Now, how can we arrive at 6 without arranging them? That is a question we should ask ourselves. That one is coming. Now, how do we denote or notation of permutation? That is, this was number 1. Number 2, we have the notation. Notation of permutation. How do we note permutation? So permutations, we write N permutation R. That is the notation of permutation. So it is written as N permutation R. In this case, where N represent the number of observation or the number of objects, total number of objects. And then we will look at how we will apply this R. So this R represent the number of chosen objects. So this This is how we denote the permutations. Now, formula we can use to calculate permutations. That is our number 3, formula. Formula we can use to denote permutation. So the formula of n permutation R can be given or is written as n permutation R is given by n factorial divided by n minus r bracket factorial, whereby n factorial is given by n multiplied by n minus 1 and then n minus 2
up to 1
multiplied by all the way to
1.
very good, and then r we've said is the number of
Chosen object.
r is the number of chosen objects. And then this one again, n factorial is the total permutation of all the objects. Now, how do we calculate these permutations now? We have the steps followed. Who can try? We have steps followed when calculating permutations. This is number 4. We have steps followed for calculating permutations. We are still at the basics of our introducing this topic, permutations. How do we calculate total permutations? Step number 1, yes?
You identify the n.
Very good. Number 1 is identify the number of objects. Identify the number of objects. And we say the number of objects is denoted by small n. So first identify the number of objects that is denoted by n. The second step, who can try? Step number 2. After identifying the number of objects n, what are you supposed to identify again? Yes, ready? R. Very good. So step number 2, identify how many objects. Identify how many. Identify how many objects are being chosen or are being arranged. Objects are being arranged. That is our R. After identifying n and r, what are you supposed to do next? Yes?
Replace the formula.
Definitely. Number 3 is use the formula. So you use the formula n permutation r is given by n factorial all over n minus r factorial. And the last one is to evaluate the factorials to get the answer. That is number 4. Evaluate the factorials to get the answer. That is a brief introduction about permutation. Now, I want us to go down to the real task on how to calculate this permutation. Example 1. I'm going to do example 1 on the board. Example number 2, you will do in pairs. Example number 3, one of you will come and do for us on the board. That is example number 1. So, for example number 1, you are being told that how many ways can 3 students, that is ABC, arrange in a row? How many ways can 3 students? How many ways? Example 1. How many ways can 3 students, that is student A, B, C, arrange in a row? That is our example number 1. How many ways can 3 students A, B, C arrange in a row? So step number 1, following the steps you've given, what are we supposed to identify first?
N.
Now, from this example, what is our n?
3.
So our n is
3.
3. About our r?
It will be 3.
Yes?
3 also.
2.
3.
Why 2?
3.
3, 2.
3 since we have the objects to be A, B, and C.
Yes, there are 3. The r will be 3 because we are choosing from A, 3 students. No, not student 1, 2, and 3. So we have our r again being
3.
3. So step number 3 is to replace in our formula that we have n permutation. R is given by n factorial all over n minus r factorial, which will be 3 factorial all over 3 minus 3 factorial. That is, what is 3 factorial? So 3 factorial is 3 multiplied by 2 multiplied by 1 divided by
0 factorial.
0 factorial. In our calculator, 0 factorial is always
1.
1. 0 factorial is 1. So the answer will be 6 over 1, which is the same as 6. So we can arrange this student 6 times or 6 ways without repeating or without them being in the same position. That is our example number 1. Example number 2. So in pairs now. In pairs with your neighbor. I want you to do for me this one. Example number 2. So our example number 2 is that. Example 2. How many ways can 2 students? How many ways can 2 students be arranged? From 4 students. Yes. How many ways can 2 students be arranged from 4 students? In pairs, I want you to discuss this example number 2. How many? So first identify n and then identify r. How many ways can 2 students be arranged from 4 students? Yes. Check. How many ways? Yes, good. You can see 12 ways. About this group, 12 ways. So, how do you go about it? First, identify n. Our n is? So, n in this case is 4. And then we have our R being, we are arranging 2 students. So, R will be 2. So, from the formula that n permutation R will be given by n factorial divided by n minus R factorial, which is 4 factorial divided by 4 minus 2 factorial, which is 4 multiplied by 3 by 2 by 1 all over 2 multiplied by 1. So you can as well simplify from this side. So 2 and 2 will go. So we have 4 multiplied by 3, which is 12 ways. So we can arrange these students, the 2 students, 12 ways. Now, I want one of you to come and do for us this one on the board. Yeah, but this one. Is our example number 3. A bench has 5 seats. In how many ways can 3 people sit on the bench? In how many ways can 3 people sit on the bench? Who will do for us that on the board? Yes?
So in our first step, we're supposed to identify what is our n and what is our r. So from the question, our n is, our chosen is 3, and then our n is 5. So using the formula NPR is equals to n factorial, minus factorial, you can replace and get 5 factorial over 5 minus 3 factorial. So 5 factorial is 5 times 4 times 3 times 2 times 1, and then 5 minus 3 is 2, therefore we have 2 times 1, so we can cancel, and 5 times 4 is times 3 is, so our answer is 6.
So we have 60 ways. Very good. Is it correct, class? Yes, only the correct answer. That is how to apply the formula in calculating the number of permutation. Now, I want us to look at what happens when the permutations are repeated. What happens when the permutations are repeated? So, the last bit on this is permutations. Permutations with repetition. Permutations with repetition. How do we calculate permutations when there is a repetition? So I'm going to give the formula directly. So total permutations will be given by total permutations will be given by P is given by n factorial all over P factorial, Q factorial, and R factorial, where P, Q, and R are the number of identical objects, where P, Q, and R are the number of identical objects. Number of identical objects. Maybe for us to understand better, I'm going to use an example. And a very simple example I'm going to use is this one. The number of permutations you get from this word level. From that word. Now, what does this repetition mean? So first, we identify our n. N means the number of objects in this word level. How many letters do we have? So you can count. We have 1, 2, 3, 4, and 5. So we have 5. And then you can see that we have the letters which have been repeated.
Yes.
So we have n. N ni ngapi?
2.
We have 2. How about E?
2.
2. And then we have
V. 1.
V will be
1.
1. So replacing on our equation or on our formula, we have that n will be 5 factorial all over. We have 2 factorial multiplied by 2 factorial multiplied by 1. That is what this formula means. So you pick the letters that have been repeated as your denominators. So we will have 5 multiplied by 4 multiplied by
3
by 2 by 1, and then all over 2 by 2 by 2, 2. Siko sawa? So this one will go with this. This one 1, 2. 5 multiplied by 2 multiplied by 3 will be 30. Yes, you have 30 ways or 30 permutations. We can arrange this the letters in this word 30 times without repetition. Now, that is, so as an assignment, to give you as an assignment, I want you to go and calculate for me this one. How many ways can the letters of the word this one arrange? So you use the formula to calculate the number of ways the letters in this word can be arranged. So this will be your assignment. So in our next class, we are going to look at the number of ways those letters can be arranged. And that is all about today. What have we learned? Yes, Diana?
We have learned about permutations.
Yes, we learned about permutations, yes.
I have learned the difference between permutations and
Combinations. So again, as an assignment, go and read on combinations. Go and read on combinations. Any question before we end?
No.
Do you have any question? So thank you. Thank you for your cooperation, and see us in our next class.